Welcome back, and it's section 3 of our lesson. We're talking here now about the potential energy. I'm going to look at the system of two charges and talk about the potential energy in that system. And here, this potential energy I'm talking about of that system of charges is given by U equals KQ1 Q2 over R. Note that this is not R squared but R, so that you don't confuse it with Coulomb's law. Now here we're talking potential energy denoted by that symbol, the U. Okay. Now let's have a look at some examples to see how we can apply these equations and formulas to solve problems, including Coulomb's law. Two metal spheres on insulated stands carry charges of plus 4 microcoulombs and minus 6 microcoulombs respectively. The spheres are arranged with their centers 40 centimeters apart, so that is our R, as shown below. Okay, now we also need to be sure how to convert centimeters into meters, okay? If it was millimeters, we're going to multiply by 10 to the power minus 3. Here it will be by 10 to the power minus 2. Okay? Microcoulombs to coulombs by 10 to minus 6. By 10 to minus 6. That's what we know. Now let's have a look at the questions. Now calculate the magnitude of the force exerted by each sphere on the other. Now this is the force, the electrostatic force, according to Coulomb. It will be given by KQ1 Q2 over R squared, and that will be equal to 9 by 10 to the power 9 times Q1, which is plus 4 by 10 to the power minus 6 times minus 6 by 10 to the power minus 6, converting microcoulombs to coulombs, divided by R squared. 40 centimeters. It must be in meters, so I'm multiplying by 10 to the power minus 2. This must be squared. Okay, so we work that out quickly. 9 by 10 to the power 9 times 4 by 10 to the power minus 6 times 6 by 10 to the power minus 6 equals. Okay, what do we have there? 0,1 or 0,216 divided by, okay, 40 to the power minus 2 times 40 to the power minus 2. That is when it is squared. Okay, it's going to be divided by 0.16. Now what is that answer? So you've got 0,216 divided by 0,16. Okay, and what is the answer there? The answer is 1.35. But it is minus because remember that is minus. So this gives us a minus there. Divided by that, it's minus 1.35 newtons, okay, of force. Now, what does this minus mean? The minus means that you've got a force of attraction. It means you've got opposite charges here, plus and minus. So it means the force is 1.35 newtons, and it is attractive. Okay, so it's an attractive force. Next, by what factor will the magnitude of the force in the previous question change if the distance between the spheres is halved? Do not calculate the new value, but let me just quickly show you how it will work here, and I'll take the general formula. Okay, Coulomb's law, like that. If you have this, so you have got F nu now, that is the F old. It will be K Q1 Q2 over, you have halved it, so it will be that, but you still have to square it. If you work this out, you'll see that F nu will be equal to, this will be 1 over 4. Then when you work it out, it's going to be 4 K Q1 Q2 over R squared. And what is this? This is your old F. So the F nu, when you halve, will always be 4 the old F. It will be 4 times. So that's what they mean by saying without calculating, just give us the factor. The factor is it's going to increase by a factor of 4. Okay, next. Calculate the net electric field at point P. Okay, how do we do that? Let's just look at this electric field of this one at point P. Electric field strength at a point in an electric field is given by KQ over R squared. This is very important for you to know. So for this first one, it's going to be 4 by 10 to the power minus 6. In fact, let me write the K there, 9 by 10 to the 9. I left that out, divided by the distance. Now from here to there is what? It's 60 centimeters. So that will be 60 by 10 to the power minus 2. Okay, that has to be squared. So you work this out, you get that. The E, this is E due to 1. E due to 2 is going to be K Q2, this was Q1, over R squared. That will be 9 by 10 to the 9 times 6 by 10 to the power minus 10, to the power minus 6 micro, divided by what? R squared. It's 60 by 10 to the power minus 2. You square that. And then when you've worked out this 2 here, remember they say the net resultant there. This one is negative, it will be pulling it in. This one is positive, it will be pushing it out. Then you work out the difference of that. You have got the net E there in that way. Okay, see you in the next section.